In this video, I just wanted to elaborate on some of the ways you can utilize linearized circuits, the ways you can convert from conventional domino chains to linearized domino chains, as well as some of the interesting properties of those chains. So this is essentially on applications of the linearized systems. So, linearized systems, as you know, are a lot faster. And by the way, this video is intended for those who have watched the previous video, which is essentially the introduction to linearized. So linearized circuits are fast, but they're not particularly useful for logic, for one. The logic gate demonstrations that you may or may not have seen all use conventional dominoes, at least in the heart of the logic section. So, if you want to combine linearized circuits with logic gates, then it becomes necessary to convert from linearized to ordinary. And I just wanted to demonstrate how this can be done. To trigger a linearized circuit with a linearized chain with conventional chain, it's very easy. All you need to do is rig up the conventional chain so that it would knock over this. When it knocks over that, it should trigger the rest. If you want to make it in a line, then you just bend it off like that. So this will trigger the linearized chain. The slightly more complicated and subtle part to this is going back from linearized to ordinary. This requires a slightly more complicated mechanism because although it's slower, the standard, it carries more energy because a block that's like this has a lot more potential energy than a block that's like that. So it has enough energy to just physically smash another chain and topple it. However, linearized contains a very small amount of potential energy, so you have to essentially, at the end of the chain, build what I like to call an energy well that will store the energy, and that will store some energy that then just needs a tiny tip to set it going, which in this case is the triggering of the linearized chain. And this is very useful. Unfortunately, it comes out at right angles, so essentially you put up a thing like that, and the one that's standing straight up, you just connect that to your standard chain. Again, I'm going to bend this off because that's what's ordinarily done, although if you set these up in a clever way and set up your gates in the right way, you don't have to do this. So this will reconvert. When I pull this, what'll happen is, right now, the height, I'm going to take camera and shift it so that you can see. Right now, the height here of the linearized circuit is what's supporting this tilting block. When this flattens out, then this has nothing to keep it, or much less to keep it from tipping, and hence it will tip over and trigger the other parts of the chain. So, let me just get things back in alignment. So, here I will now test this. Well, I've done it before. So, you want to make sure this is tipping enough, not enough to tip over the linearized chain because that would defeat the purpose. But if it's not tipping enough, and if you've seen my linearized transmitter and gate demonstration, the simultaneous demonstration, you'll see there's an error in which this does not go far enough over to trigger that. Fortunately, it did not impair the AND gate demonstration. So that is a major component of using these linearized systems in relation to logic gates. The one last thing is that these linearized circuits have a very bad turn radius. They turn very slowly. You can actually bend them very slightly by I'm putting a tiny adjustment like that. But this, it slows it down, and see, it's bending very slightly. But this is only good for very slight adjustments because the turn radius is huge. Ordinary dominoes, in contrast, have this nice tight turn radius. However, you can get these linearized circuits to bend angles with a little trick. And this trick is you do this. You have to actually create 3 independent linearized circuits. So for a right angle, what you do is you would build another one that's facing in exactly the opposite direction, like this. Then you just trim this complex so that the gap in between those two on the top edges is slightly less than the width of the block. So over here, this gap distance does not have to be that special. The closer it is to this one, the closer the heights will be and the more stable your circuit will be. But, I mean, if you're not worried about that stability, you can just use one flat block if you're worried about compactness. So what you do is you just set this up as normal. And so now I've gotten my linearized circuit to turn a corner. When this collapses, this will not actually go straight down, it'll twist off to the side. But that doesn't matter because it'll still trigger. And this is very reliable. It's more reliable than converting back to ordinary dominoes to turn corners, which is what I used to do before I found this out. So that works nicely. It also works for oblique angles as well, which is quite useful. Again, you just you simply have to adjust the angles in such a way. Now, for angles that are obtuse, you'll notice that I'm using the back edges of the block. For acute angles, you'll want to use the front edges of the block. So this is the obtuse demonstration. So this will work fine too. What I mean by using the acute angles, if it's not obvious, is if you have a chain set up like this, and you want it to bend back like that, you will want it to be like that and use the forward-facing edges instead, like that. I mean, it's just common sense. You wouldn't be able to do it any other way. So that'll work too. The last interesting application of these linearized things is as a diode, because unlike ordinary dominoes, these do not work both ways. So far, I have not actually come up with a situation in which to apply a diode for dominoes, but I'm sure it will crop up eventually. So, of course, if I tip this, nothing happens to these. There's no way that I can make it affect the others in the opposite direction. So what you can do is you can rig up a reconverter like this, and then a trigger like this, and what this will now act as a diode because if I hit this, it will trigger, it will follow through there, but if I hit this, it will not. Even if this did cause this to collapse, which occasionally it might if it's a turbulent enough triggering here. Even if it does cause that, it will not topple these because these are not in direct contact. So if I do hit this, nothing happens. Whereas if I went and hit this, it would go through. So that's kind of like a diode system. So those are the applications of linearized circuits and how to adapt them to various uses. So yeah.